Say hello to the world of software. This video is an introduction to creating software for robot teams for students that are just starting out learning to program with Citrus Circuits, FRC Robotics Team number 1678 in Davis, California. So let's pretend you're totally new to programming and the systems that dwell under its spell and look at some tips on how to learn how to program more easily and more quickly. My name is Jamie Zachary Fox. I'm a software mentor with a team. Please note, not all of the words that will be displayed will be spoken. So pause when you wish, take time to ponder, read the things, think about them, and then move on. So think about it this way. The purpose of software is to direct, to instruct a machine, a robot, a thermostat, a cell phone, to do something useful. How does that all happen? Well, stay tuned. We're going to look into the beginnings of it. The Citrus Circuits robot developers write the code that controls the robot, handles the motors, the manipulators, manages the power, controls the pneumatics, and so on. These programs determine how the robot goes about doing the things it does. Plus, the developers use outputs from the robot's sensors and its logs and its vision to understand what it's doing and then make refinements. Currently, the programming language being used for the robot is C++. Also, the Citrus Circuits Scouting Team develops mobile applications and a server infrastructure used for judging other robots during competitive play in order to pick those teams most advantageous for an alliance. If you're new to understanding an alliance, it's a cornerstone of the FRC. Scouting offers foresight into the capabilities and possible strategies that opposing alliances may use in an upcoming match. As of now, the languages being used by the scouting team are Java, Python, Swift, and TypeScript. Learning to program typically starts with writing code that displays "Hello World." It is indeed a new world. Allow me to introduce you to it. Programming is challenging. It's inspiring and engaging. Those who like it do tend to love it. But there is a lot to learn. It is a very extensive field. But if you take the time to solidly learn the fundamentals, programming becomes easy and learning new languages becomes straightforward. You will make many errors while you learn. Stay patient. Don't let others rush you. Everyone started off not knowing a thing. Programming will be a new way of thinking. It will also demand the practice of exactitude, being exact in what you write, being exact in punctuation. It takes a while to become accustomed to working this way. So please remember the allegory of the tortoise and the hare. Programming is indeed one area where it's advantageous to start slow, learn the basics, master your tools, and read code. There's much to be gained by reading a lot of code before trying to write too much. You will wind up going faster. So for software, let's for a moment think beyond programming. Developing software challenges the mind. That's a big part of its appeal. Authoring software will teach you to think clearly, to write concisely, to design creatively, and to finish what you start. You'll learn a lot about software systems. You'll learn their parts and the relationships, the flow of control, the processes that are used with other people, and the tools of the trade, such as editors, or what we call IDE, and an integrated development environment. Debuggers will help you find and fix code problems. You'll work with code repositories. You will peer review other people's work, and other people will peer review your work. And you will use design sketches and other tools for thought to help your thinking become more refined and more focused. As Bo Dalba mentioned, you can't do much carpentry with your bare hands, and you can't do much thinking with your bare brain. So we use specific mental models. For example, rubber duck debugging is for getting unstuck. Scope is a way to determine a range of impact. Collections are ways of organizing and handling data. Regex, or regular expressions, are used for pattern matching. State machines for understanding transitions, and so on. It is quite a list, but if you take them one at a time, learn what they mean, and practice with them, then they'll start coming out and making a lot of sense to you. Because what it all comes down to is we're going to be designing systems, authoring programs, translating those into code, and then collaborating with your teammates to get things done. You will, however, find that acronyms and jargon do in fact abound. you'll encounter myriad acronyms. Take the time to learn what they mean. For example, you'll encounter JSON, which stands for the JavaScript Object Notation, or API for an Application Programming Interface. At the bottom of the list, you'll see RESTful, which stands for Representational State Transfer. Another thing that you will find when you're learning to program is certain things tend to happen with each other a lot. For example, JSON, API, and REST are often used with each other, and that's because they form part of an overall system. Also, you will encounter that familiar words will take on very specialized meanings. Worse yet, sometimes they'll mean more than one thing, and their meaning depends on context. Static, for example, means unchanging. We call it immutable. A stack, well, that could be a memory architecture or a set of technologies. A class, a technique for organizing data and methods, and a pattern, effective way of doing things, and so on. Again, very specific meanings for words that you're used to using in other ways, at other times, in other places. So, what's a program? A program is a recipe for action. It's a set of exact and explicit instructions that tell a device to do something. One useful approach is to think of programming as covering three distinct but interrelated ideas, or actions of structuring data, the flow of control, and manipulating data. You'll find it's a good idea to always playing the role of the curious one with yourself and asking, like, what am I working with right now? Is this a thing or an action? And so on. This recipe is written in code. Some tips. Start off beginning to understand how software works, what the terms mean, what algorithms are, what the parts of the system are, the tools you'll use, more so than just jumping in and learning to code in some language right away. Stay curious about what you're working on, not just how to do the thing you're trying to do. Why is it you're doing the thing you're doing? Keep your mind there. Take the time at the outset to become proficient with your tools, especially your integrated development environment and the debugger. They take practice. Practice with them. Also, recognize that numerous computer languages do similar things in vastly different ways. It's more beneficial to learn programming concepts than focusing too much on coding skills right at the beginning. Always make a quick sketch of what you're trying to do prior to writing any code. Whiteboards are your friend. And also, never expect anything to work correctly the first time. Be skeptical if it appears to. You will become acquainted with many patterns. For example, one common pattern in writing software is that you'll create something, and then you'll set it to something, and then you'll use it. And in some languages, you'll then have to dispose of it. It is easy, and this is a caution, to become code blind, which happens when you've stared at a code snippet for so long, your brain no longer can recognize the problem right in front of you. So take breaks, get away from the screen. While you're learning to code, also pay special attention to any kind of punctuation, every time, all the time. And try to stay mindful of where your attention is focused. You will encounter many coding conventions. They matter. Memorize the rules. Take your time. If you encounter a style guide which will tell you about, say, indentation, follow it. It's there for a reason of making your code manageable and maintainable. Capitalization and case matter. Develop and keep a keen eye for detail. Also, white space is your friend. When you're writing code, don't cramp things. Leave plenty of room. It'll help you in the future. Be extra, special, careful to keep your nouns, which are things, distinct from your verbs, which are your actions. Let's begin with a couple overall guidelines. In software engineering, rule number 1 is called separation of concerns. It's fundamental. It means to focus on a single intention. Make a module do only one thing, but do it very well. And there are some other guidelines. We talk about being sufficient to purpose. That means focus on the immediate outcome, exactly what you need, not some pie-in-the-sky hope for a future or grand design. Dry, don't repeat yourself. That means avoid duplicate code. If you find that code is being written again, that usually calls for what we would say is refactoring, which is simplify it, and yagni, which is slang for you ain't gonna need it, which means don't over-design. So writing code, what's that about? Programming, essentially, is authoring text in a highly specific manner that instructs computing devices to do something. We call that change their state. It's a very powerful skill to have. So if you're new to learning to code, here are a couple suggestions. Start with Python or perhaps JavaScript. Search Google for tutorials and read through them. Stay keen to specifics, especially about punctuation, capitalization, and how things are named. Go back then and work through the tutorial on your computer, step by step, staying attentive to what you're learning, what things are called, and try to recognize where your errors typically occur. That's where you need to focus. Look at GitHub for interesting code and read a lot of it. Take the time to really learn how to organize your data using classes and collections and related functions. And also continue to practice. Practice is what makes coders become expert developers. Now, programming, what's that about? Programming organizes coding activity into a coherent whole so that pieces work together, data integrity is preserved, and produces results that are sufficient to purpose. How do you do this? Well, following the advice from Josh Waitzkin's excellent book called The Art of Learning, start with the end game in mind. Here's a stepwise approach. Specify an outcome, the result of your code. Then write in unambiguous details a pass-fail test for that. Then sketch out a diagram of the parts and the relationships on a whiteboard or with a drawing app. Open a file in your IDE and then add comments about what will go in each section. Here are the class definitions or the parsing functions or the computations or output formatting. Now, return to the top part of your IDE and start writing code in the language of your choice between these sections of your comments, and then test it. Even better, move testing into item number 2, where you begin with a test and have test-driven development. And then, as they say, lather, rinse, and repeat. But remember, you're communicating with a computing device. You're talking to a machine. So let's talk about computer languages. Begin with considering the basic model of communication. A source, that'd be you, sends a message, that's your code, to a receiver, such as a robot, scouting app. A source, that is where the intention is. That's you. That's your design. That's your code. The message, well, that's the program. That's things that are packaged up and what goes where and how things are said in a way that the machine can understand it. And then you have the receiver. This receiver does not understand much and it has very, very picky requirements about, like, symbols. You're going to encounter new arrangements. Like when you look there and you see that hash and the exclamation point, we call that a shebang. And then reading across the line, you have logical and, logical or, not equal, is the same as, is the same thing as, arrange, the beginning of a comment, and so on. Also, syntax matters. The grammar of structuring what goes where and how to say something has to be done exactly with explicit punctuation. Semantics are the meaning of how you say something. What are the particular approaches in one code base or another code base to get something done? And then, of course, there's pragmatics, which you can think of as smart or dumb ways to do things. Usually that's called architecture. The essential thing to keep in mind when you're dealing with programming is that you, as a source, must encode your message in a manner that the receiver can interpret and understand it, all the while remembering how picky it is about symbols and syntax and pragmatics and so on. So if we're going to be talking about computer languages, when you think about code, think about language. Use the model of parts of speech. Nouns are the names of things. You'll see variables and constants and classes and lists, and it goes on. And then you have types of things. They're integers, decimals, booleans, characters. These are all things and types of things. Then you have actions. You could think of them as verbs. Depending on your language, this might be called a function or a method or even a subroutine. Now, these would be things like append to a list or get a URL or print a particular line. Then you have conditionals, which are ways of determining what you're going to be doing if then or while you're this or try this and catch that. Where to really pay attention, though, when you're starting programming is with punctuation. Punctuation can be tricky, mainly because it's used in three very different ways. You have some punctuation that is used for structure, to create structures and parts and segments of a program. You have other punctuation that's used primarily to make decisions. Is this the same as, greater than, less than, one of, and so on. And then yet a third element is you have punctuation used as operators. Add this, multiply that, divide something else, subtract something, and so on. So you have nouns, you have verbs, and you have punctuation. And the punctuation is tricky and used in very contrasting manners. Also, it's important to point out that software development really isn't for everyone. You need to work with code a while to see if it fits your own personality, because programming is a very hard path if you're not a good fit. To begin with, programming requires quite a bit of personal discipline. You need to focus on learning things, you need to learn how to finish things. It requires an eye for detail with a patience for the exactitude in writing code of getting things just right. It requires quite a bit of finger dexterity and learning to type accurately and quickly. Visual acuity to be able to read a screen and discern important subtle punctuation. And the time scale of learning. It takes years to become proficient. The continuous development and change means you are constantly learning new things. That's what's required to keep current. Perhaps you could say it's more like learning to play the violin than playing the drums. As anyone with a young sibling knows, give a child a pot and a spoon and suddenly you have a drummer. Drums are probably the easiest instrument to learn how to play, despite playing them really badly. Actually, playing drums is very hard to do very well. But you think about a violin, that's hard to do on day one. You can't just hit it. It's very difficult. And it becomes a challenge to learn the myriad things of controlling pitch and controlling pressure. Actually, music is a good analogy for software, because one thing that all musicians recognize is you're facing a life of constantly improving. You recognize you can always get better, so it becomes a driving force for continuous improvement. Software shares much of that. You may find this excites you, you may find this frightens you. Take the time to figure out which it is and then move accordingly. Software has become the heart of everything, and software developers are the heartbeat of the future. They're the ones who make the software work, to make the machines work. There's a lot of skills, and working with software and working with a robotics team, you will develop all of these. You will develop code writing skills and logic skills and problem solving skills and people skills and concentration skills. All of these are learning skills. The First Robotics competition describes itself as the hardest fun you'll ever have. It is challenging. Everything about a robot is a challenge. Everything about a robotics team is a challenge. It is hard, and it is also incredible fun. Here are some learning resources. The most important one is to start off by thinking that software development is a creative act where engineering and art join together uniquely and matter equally. Engineering is measured, repeatable, elegant, art, unique, aesthetic, expressive, and inventive. These come together when you're writing software. The most important source, though, of learning is your teammates. Seek them out, work with them, and that's where you're going to learn the most. So after all this, let me say that there's only one thing you really need to do to excel at software, and that is start with the end game in mind, or look down the road. My name is Jamie Zachary Fox, and thank you for taking the time to listen to this, and I wish you well as you join with First Robotics. It is an amazing experience. Hardest fun you'll ever have, fun you'll never forget. Thank you for listening.